All right, so hello. I'm going to go ahead and get started and introduce our guest today. Thank you for joining us for our next installment of our Friends of HSF Alumni Speaker Series. We're so excited to connect our alumni directly with our students in this virtual Q&A format. Today, we're going to hear from alumna Olivia Rose regarding careers in STEM, navigating STEM as a female, and ways to maximize your undergraduate research. Thank you to those of you who submitted questions ahead of time. If you submitted a question today and it goes unanswered, please feel free to submit that question via the chat feature. If time allows, we'll be submitting these questions to Olivia live. Our student moderator for today is Jessica Dixon. Jessica is a third-year student and Goldwater Scholar from Melbourne, Florida, double majoring in cell and molecular neuroscience and statistics. Jessica is involved with Presidential Scholars, Neurosci, the Honors Experience Program, and President's Ambassadors. Thank you for being here, Jessica. I'd now like to introduce our guest for this afternoon, Olivia. Olivia is currently a Ph.D. candidate in neuroscience at the Washington University School of Medicine. During her freshman year at FSU, Olivia participated in UROP as her first introduction to research. 5 years later, she is a doctoral student in a neuroscience program currently ranked 9th globally. FSU's commitment to undergraduate research is the reason Olivia is where she is today, particularly due to the support and mentorship provided through UROP and the CRE. Olivia received her BS in psychology from FSU in 2018 and currently conducts computational neuroscience research in the lab of Dr. Carlos Ponce at Washington University in St. Louis. Her research integrates classic electrophysiology with cutting-edge machine learning and computational modeling to understand how the primate cortex encodes and transforms visual information. Like in many STEM fields, computational neuroscience reflects stark gender, racial, and socioeconomic disparities. She's no stranger to being the only female audience member in the seminar. Consequently, Olivia is passionate about mentoring undergraduates, particularly those from underrepresented groups who are interested in careers in STEM. So thank you so much for being here, Olivia. I'm now going to hand it over to Jessica.
Thank you, Amy, and welcome, Olivia. Before we get started, participants, please know that you can ask questions at any point by submitting them in the chat to our hosts. Feel free to ask questions there, and we'll do our best to get to them. I'd like to start by asking you, Olivia, can you please share briefly about your experience in undergrad and how you got into a career in STEM?
Well, thank you so much. Thank you, everybody, for attending. I am just so excited to be speaking to all of you. So I began my undergraduate career thinking that I was going to be a poetry professor. Not exactly the start that you expect for a computational neuroscientist, right? An English major. Well, unfortunately, movement disorders run in my family, and I became very passionate about studying the neurobiology of movement disorders during my undergrad, and I made the switch from English over to psychology. The neuroscience majors, the cell and molecular and the systems neuro major, weren't there when I was an undergrad. So it was basically either a biology major or a psychology major. And I decided to go with psychology. So I participated in research during my freshman year. I was part of the UROP program, the Undergraduate Research Opportunity Program. I can't speak highly enough about it. If you are an incoming freshman or a current freshman and you want to participate in it, it is fantastic. I'm not sure when applications close, but you should totally look into it. I also, for all of the resources that I speak about today, I have a little Word document that I typed up and put links to. So you'll all be able to get a copy of it afterwards, and hopefully it'll help serve you as you go through your undergraduate career. So I began in UROP. I started out in a clinical psychology lab. I was studying EEG markers of different neuropsychiatric disorders. And then I started getting more into the cognitive neuroscience domain. I did a brief stint in a wet lab where I was doing neuropharmacology and found out that I am not too great at wet lab and pipetting techniques. Not for me. So continued on with human EEG and started to get a little bit into MRI. And then I realized that in grad school, MRI wasn't quite right for me. So I had the opportunity to do my last rotation in my current lab, and I fell in love with it. So now I am in a computational neuroscience lab. And actually I have a couple slides if you guys want to hear about my research that I'm currently doing, just briefly.
So that really relates to our first question. Our first question is, how would you how can you get involved in undergraduate research quickly, and can you do it their freshman year?
Absolutely. You can get involved in research from the very get-go. Like I mentioned, UROP is a great program. It's very structured. So you have class, I'm forgetting now if it's once every 2 weeks or once a week, something like that. But you have class, you have older UROP students who came back and decided they wanted to be UROP leaders. They then basically hold your hand and walk you through the process of getting a lab and how to read scientific papers and how to put together a poster presentation. And then ultimately it culminates in the ability to present that poster at the UROP symposium. But you don't need to be a part of UROP. It's becoming increasingly competitive in recent years. So if you don't get in, that's totally okay. That doesn't mean that you can't do undergraduate research. That's just a matter of take classes, find professors that you really feel a connection with, that you are interested in their research, and you just email them or go up to them after class and say, hi, can I just, talk to you in office hours about your research? It seems really interesting. Go on PubMed, read some of their papers, see what you like out of it, if it's a technique, if it's a conceptual advance, and then go and ask questions about it. And the more detailed your questions, the more that you show that you've read their papers, the more likely they're going to want to take you on as a student to mentor. And it depends on, how their lab is structured. Some professors are more hands-off, some are very hands-on with their undergrads. So it's just, find somebody that you think is interesting and ask them if you can get involved. It's sometimes just as simple as reaching out to somebody and, you can end up with a publication.
Our next question also relates to joining a lab, particularly in this environment. They want to know, how can you get involved in research when everything is online?
That is such a great question, and it's something that I probably don't have any great answers to. Obviously, in COVID times, this is insane. Everything is virtual, and it's very hard to get started in something when you can't even meet with a professor face to face. So that being said, now is the time to go educate yourself as much as you can by reading papers and learning new skills that you can online, like programming or statistics. And then, reaching out and seeing if you can have a Zoom chat with some of these professors that you're interested in. Maybe they can get you started coding data, which is usually how a lot of undergrads start their research, or doing some sort of offline data analysis. And when everything starts to open back up, you might have the opportunity to actually go into their lab. I don't know how professors are handling this right now, because this has never really happened in our lifetime. But if you reach out, a lot of them are just really excited to have students that are interested in what they're doing. And we'll probably figure out some way to get you involved, even if that has to wait a little bit.
Can you use this opportunity to show your slides talking about your own research?
Great. So let's see, move that bar over. Wonderful. Here we are. So I hope you appreciate my pun. I worked very hard on it. But basically, I want to dedicate this talk to the memory of Dr. Karen Laughlin, who is a very dear mentor to me and whom I miss very deeply. But, oops, there we go. So a little bit about what I do in lab. So to the left, you see a picture of me with my cute little protective equipment on, my little face mask and my eye goggles. And then to the right, you see something that kind of has the lion on top, 2 holes for the eyes and ish, and some sort of thing covering the bottom half of the screen. And it's a lot of features that are the same shape as that photo, right? Well, the picture on the right, I used machine learning to pull out of a monkey's brain. So this was taken out of a neuron by the fancy techniques that we use, and we found that particular neuron encoded something that looks a lot like our faces in the protective equipment we wear around our monkeys. So I study vision. I am a visual neuroscientist. I study how when retinas hit your, or sorry, retinas, wow, I need more coffee, obviously. When photons of light hit your retina, how that pattern gets transformed by your brain into this, you know, cat with its face and piece of bread, or whatever you're seeing in the daily world. We do this so automatically, it's instant. But the way that light hits your retina isn't the way that it gets transmitted into your brain to begin with. It starts off and your brain processes vision with a neural code. It's not just this complete picture in your brain. It gets processed and synthesized. So I research to understand how that process happens. If you have any neuroanatomy, great. You'll probably remember the dorsal versus ventral streams. If this is brand new to you, that's totally okay. So vision in the primate brain is processed in two ways. You've got the dorsal where pathway and the ventral what pathway, which studies object recognition. I study the ventral pathway because that tells me how the primate brain recognizes visual objects. So quickly, photons of light hit your retina. There's this process called phototransduction that transforms the photons into an electrical signal that your brain can read. That information gets transmitted through your optic nerve into the first stage of visual processing. It's called the lateral geniculate nucleus of the thalamus. Don't worry, there's no quiz. From the thalamus, that information gets transmitted to primary visual cortex, which is where I come in and start studying. So I have electrodes here in primary visual cortex, right on the border of V2, another set of electrodes here in V4, and then another set right around here in this area called inferior temporal cortex, abbreviated here with posterior IT. So I've got electrodes in those three locations, and I hook it up to fancy machine learning to understand how our brain encodes visual information and how those representations are transformed as you move from one stage of processing to the next. So the way this works is we show a bunch of images that kind of look like textures, so that, well, highlighting one specific, we call it a single unit or a multi-unit, but you can think of it as just like one neuron or very small population of neurons that we're listening to. So we have that one in a little spotlight. That's the one we want to investigate. So we show these textures to the monkey. The monkey is staring at a computer screen. The neuron fires more to some textures and less to others. That information as to which pictures the neuron fires more to gets fed into a particular type of search algorithm. That algorithm serves to maximize and optimize, finding out which features of the images are maximally exciting that neuron. That then gets sent back into this class of machine learning technique that we have called a generative adversarial network, also called a GAN. If you're familiar with like deep fakes or any form of like the artificial, this face does not exist, image generation, it's the same class. That GAN then synthesizes a new class of image or a new type of images. Those images are shown back to the monkey, and the process starts again. And basically over time, it leads to something, the generation of something that looks like this image on the right, where it starts off with at the very top, you've got these textures that don't really look like anything. And over time, it selects for the features that maximally excite that neuron until you get something that looks like these final images here. And it's a really cool one. This is one of my favorite, we call it evolutions. And it is this flexible, but really informative piece of information that tells us this is how this particular neuron selects for things within the visual world. This one selects for circular objects, and more so than any natural images in the real world. So we know, and I'm not going to go into full details, I'm already talking way too much about my research, but we have a paper coming out soon that will go into a better, more detailed explanation and show some of the statistical techniques that we use to show that this technique brings about the true meaning of what these neurons in the visual cortex are encoding. So I'm going to stop sharing my screen, and we're going to move on to the next question.
So it is obvious that you have this incredible passion for research, and we know that started at FSU. You mentioned earlier UROP, and I was wondering if you'd explain what UROP and the CRE are in more depth.
Absolutely. So I talked a little bit about it previously, but UROP is just this very structured way that kind of holds your hand as your first introduction to research. And it's by application only, but if you're accepted into it, it's just this amazing program. It helps you every step of the way from finding a research position to then going and even presenting your own poster presentation. So it's a wonderful thing. It's a fantastic community of people, very, very encouraging. It is a wonderful first introduction to the crazy world of academic research. And you don't have to do STEM research to do it. You can do creative research, you can do social sciences, it's wonderful. Research does not end with just the traditional STEM and biomedical research. And the CRE is the parent organization that puts on UROP as well as other programs. If you're familiar with the organization SCIRC, it's the Student Council for Undergraduate Research and Creativity. That's also just absolutely made possible through the hard efforts of the people at the CRE who broadly help to facilitate undergraduates getting involved in research and research-based creative endeavors. So they're wonderful. You can go to any of them and say hi and ask, how can I get involved in research? And they'll have a million resources to direct you.
Our next question also involves undergraduate research. You touched upon it earlier, but can you expand in more in-depth manner on what your focus of your undergraduate research was and what faculty you worked with at FSU?
So I primarily focused on the human electrophysiology side of things. So I did 4 years of EEG research. I worked with Dr. Brad Schmidt for my first 2 years. And then my last 2 years, I did my thesis with Dr. Wen Li. She is so wonderful. She taught me everything I came out of undergrad knowing. So wonderful, wonderful, wonderful woman. I also did a little bit with Zushin Wang, who does neuropharmacology research in prairie voles. That was really fun. He's a fantastic mentor, awesome lab, and I'm so bad at pipetting. I'm so sorry, you guys. I probably screwed up your data for weeks. But that's okay, because that's part of the learning experience. So my undergraduate major, like I mentioned, was psychology, but because there wasn't a neuroscience major, I tried to make my degree as neuroscience-y as possible. So I took a lot of courses outside of the psychology major. I ended up taking 3 courses offered by the Neuroscience Ph.D. program at FSU. That was amazing. It was an amazing opportunity. My personal favorite was there's a computational neuroscience class that if it's still being offered by the Department of Applied Mathematics, I highly recommend if you have programming experience to go check it out. When I took it, it was taught by Richard Bertram, who is just a phenomenal mentor and so brilliant, and the class was an absolute joy, and I really credited this to being one of the reasons I got started down the computational path.
So you've had experience joining several labs at FSU. Our students are curious about your strategies for approaching a professor to ask about a research opportunity or internship.
So the best way to do it is just be excited. You know, it sounds like so cliche, but it is the kind of thing. I have heard so much feedback from the professors that I have worked with, the professors that I've approached for rotations, even the letter of recommendation that my PI wrote me for an application. And the number one thing that they talk about is just my excitement and my passion for the research. And it makes you stand out when you are like, oh my God, this is the coolest thing in the entire world. Can you tell me more? And they remember you. And it's the kind of thing a professor's going to want to bring somebody on, even if they don't necessarily have the same skills yet. As long as you want to learn, that's going to be what indicates to most professors, I want to take this student on as a trainee. It's not about it's not about the skills you're bringing, because honestly, you're an undergrad. You don't have any research skills yet, and you shouldn't. You really shouldn't. You're not at that stage yet. Even me, I'm going into my 3rd year of grad school. Oh my God, I started my 3rd year of grad school. And it's the kind of thing I'm not even expected to have the same kind of skills that somebody towards the end of their PhD or postdoc has. It's not how it works. You're there to learn. So undergrads, there's no expectation. They just want to show excitement. They don't care how much you might know or don't know. Just, are you excited? Are you going to show up every day? Are you going to learn? Are you going to do the hard work?
It sounds like research experience is really fundamental to your journey at FSU. Beyond research, though, what organizations, clubs would you recommend to be involved in as a STEM major?
Well, honestly, if you want to go into a research-based program, most of my, I don't know how much of my advice will be applicable for anybody wanting to go the medical route or the professional route. This is primarily for people that are interested in a PhD that has a research focus, or even a master's with a research focus. But basically, what I recommend to you is get involved with the organizations that matter to you. They're not going to say, oh, well, this person was involved with the Neuroscience Honor Society, but this person wasn't, so we're going to automatically admit the person in the Neuroscience Honor Society. It doesn't work like that. It's who you are as a person. And honestly, it's just showing that you care and are dedicated to certain causes and hobbies that interest you. There's no set mold that you need to fill. And sometimes having a very obscure hobby or having some cause that you're really passionate about that you can then tie into your research, that's a great way to make you stand out from the crowd. So, if you love swing dancing, go swing dancing. Go swing dancing and then talk about, how you want to be a Parkinson's researcher. Because I'm telling you, when I interviewed for grad school, I met with the professor here at WashU, a top 10 university, who researched swing dancing therapy for Parkinson's. So go for it. Do the things that you care about and that you love. And, and the rest of it, just show that you know what it's like working in a research lab, that you can formulate your own hypotheses and ideas, and everything else, just do what makes you happy and makes you feel fulfilled.
That is great advice for students looking to join graduate programs and get the right extracurriculars to prepare for them. Just do what you're passionate about. But once you get to the point of getting your doctorate in neuroscience, what career paths are available?
There are so many. You are not just shoehorned into, the old adage of, I have a PhD, so I guess I now have to be a professor at a university. It might be the right path for you, and if it's not, that's perfectly fine. That is not the only path. You can go into research in either a university setting or in the private sector and work for a company. You can go work in industry for a pharmaceutical company or for a biotech company. That's a path that I'm potentially considering if I decide I don't want to go the professorship route. You can be a staff scientist. So if you want to do science your entire life, but the idea of writing grants just makes you really want to reconsider the field you're in, go be a staff scientist. You get to be there with your hands in the field doing all of the work that you love, publishing papers without worrying the lab's going to fall apart if you don't get a grant, because that's not your responsibility. So let's see, we covered, there's also teaching. If you have a PhD, you can go teach at a university if you decide, well, don't really like research, I'm done with that, I no longer want to do that for the rest of my life, but I love engaging with undergraduates. I love teaching this kind of material. You can go be a professor. You can go into science communication. You can go into the publishing business, the scientific publishing business, and work for one of these scientific journals like Nature Neuroscience or even Nature itself. You can go into policy. You can learn and really bolster all of these important skills during your PhD that then you might do nothing that relates back to what your PhD was actually in, but the skills that you learned in that process can bring you into another career entirely. So, if you go into, into the computational neuroscience route and you decide, okay, I'm done with the brain, you can then go into the tech industry and never have to touch brains again in your entire life, but you have the skills for it. And that's really it. Like, a PhD is a very functional degree. you learn skills and you learn them really, really, really well, and you become an expert in a very, very, very narrow topic. It doesn't need to generalize, but the skills that you have can. And that's what's going to take you into whatever makes you happy at that stage in your life.
Thank you for expanding on that. It looks like there's a lot of great careers that are available to individuals that get a doctorate in neuroscience. Our next question cycles back to your extracurricular activities. They were wondering if you have experience getting volunteer hours in STEM, and if so, how did you find those volunteer opportunities?
Absolutely. So most of my volunteer hours were done in lab or through the UROP program, because I was a UROP leader for 2 years. It was hands down one of my favorite experiences ever. I love it. But, you know, other ways than that, you can do the basic, you know, medical school, like pre-med route, where you volunteer in hospitals or volunteer in clinical places. You can go and work with, you know, I'm sure there are clubs that have more of an outreach focus for if you want to work with populations that have certain disabilities. There's a lot of options. It's up to you. There's no wrong answer. That's really it. Like, I can throw out all of these ideas, but there's really no wrong answer. And I'm not going to know everything. I don't know. I mean, now I'm out of FSU a couple of years, so I don't even know what's changed. But if you see something and you think that's something that you want to get involved with, do it. It's not going to hurt you.
Our next question relates to how you personally narrowed down to find your major and future career when there's all of those different options that you spoke about earlier.
Absolutely. It can feel really overwhelming sometimes. But for me, I didn't have as much of a choice. It was really just between biology and psychology. And under the biology major, in the form that I experienced it, there was really only one class that had a neuroscience focus, and everything else was just biology more broadly. So I decided that the best thing for me would be to do a psychology major where I could focus on the more behavioral and systems level. I got a great introduction to cognitive neuroscience. I learned how to design a task really well. I learned how to, there's a lot of biologists that are brilliant biologists and have no training in behavior. And when they try to bring a behavioral spin to their paper, it falls flat because they don't have that kind of training. So I feel very fortunate that this is where I came from and that I've been able to implement it in my research. Now that there's 2 different tracks within the neuroscience major, or you can choose biology or psychology, and I know there's more health-related majors out now. It's overwhelming sometimes. Really, it's just thinking ahead. You're not going to make a wrong choice. So basically, as long as you show that you have the basic classes and the prerequisites to get into a program, they're not going to care whether or not you majored in systems and behavioral neuroscience when you realize more down the line that you're more interested in the molecular focus, or you're going to be fine. So I would say just find ones that when you're going through that particular major's required classes and the electives, that you find yourself getting excited and wanting to enroll in those classes. And if you see more classes that make you worried and disinterested than classes that interest you, it might be time to consider a new major. But if you're looking through it and you're like, oh my God, I want to take this class. Oh my God, I want to take this class. Oh my God, I want to take this class too. I don't know how I'm going to have enough time for all of this, and I want to do a lab. That's when you know you're in the right major for you.
That is great advice, especially for so many students that are in the process of deciding what direction they want to go into. Though once a student has decided on STEM, they would probably be curious as to what your experience was as a woman in the STEM field, specifically neuroscience.
So I fall into a very specific branch of neuroscience, the computational neuroscience wing of it, which happens to be more so than other branches of neuroscience, less inviting towards women and people who basically aren't straight white men. It's an unfortunate reality, and it's slowly starting to change, but you really do see a lot of stereotypes and gatekeeping. Other branches of neuroscience and biology are a little bit better balanced, but you do experience more pushback as a woman. I know I struggle to be taken seriously right now. I'm really joking and, you know, laid back with you guys, but in a formal environment, I find myself being asked disproportionately more skeptical questions than my male peers. It's the kind of thing, you get your own research explained back to you incorrectly and very confidently. You get talked over. That's probably the biggest thing that I experience. I get talked over a lot. And it's the kind of thing where you're kind of like, you know what, most days you can kind of just put it on the back burner and say, I'm not going to let it bother me. And then some days you feel angry about it and you just wish that when you spoke, people listened and didn't just wait for, or barely wait for, the opportunity to immediately interject with why you're wrong. So it's not everybody by any means. It's not even insurmountable. It's just enough to sometimes put a little bit of a bad taste in your mouth. But if women and people of color and people with disabilities and people from backgrounds that don't fit the mold don't say, you know what, I'm just going to get through this, which is unfortunate because it shouldn't be that kind of prerequisite. You should not have to just say, I'm going to put up with this in order to do the thing that you love. But if we don't, we're going to get pushed out. And I don't want to live in a world where people like me, people like my PI, get pushed out of research just because somebody decides they don't like it when a little blonde girl has a good idea. So I don't know. I don't want to be depressing about it though, because it's not. It's really an engaging, fun thing, and really there's something so satisfying when you turn out to be right and somebody has to come to terms with the fact that they were really being sexist towards you and now they see you just thriving. It's very empowering, but there are bad days, but that's with everything, you know? So if you're gonna go through it throughout your life anyway, you might as well do it in the field that you love. But that's the right choice for me. And I want to make it so that way nobody down the line has to experience the same kind of pushback that I've experienced.
Thank you so much for sharing your experience and your empowering message. Given the sexism that you've had to experience in the field, what advice would you give to someone just entering the field? And how have you become successful in STEM in spite of that?
So my approach is, my friends know that I affectionately refer to myself as a tough broad. that is my epithet. That is my identity. I am the tough broad that doesn't let anybody get away with it. But, you know, that might not be what's right for you. For me, if somebody talks over me, I put my finger up and I say, excuse me, I'm talking. Or sometimes I'm not even that polite. I will sometimes just talk right back over them and louder. I will call somebody out and say, I said that 10 minutes ago. You ignored me. You told me I was wrong. Now it's being repeated by, you know, the male grad student and everybody's agreeing with it. That's wrong. But that's my particular style. That's what I found to be successful. And honestly, that's how I feel. That's how I feel at the end of the day helps me get by. Because if I can't be respected automatically, maybe I'll be respected a little bit more if they know they just can't get away with it. But my advice for you, if you are a woman or a person of color or a minority, or your parents aren't educated and you're trying to enter a field where it feels like everybody's parents are doctors or engineers, and like you're not being taken as seriously because of things you can't control, just build up your support system. You can't control how people are going to react to you in the field that you enter. but you can control who you go home to, who you go to when you've had a bad day and it just feels like too much. And those people are the ones that help give me the strength, and I'm sure they can help you give you the strength to keep on going and say, you know what, I'm not letting some crusty old man determine whether or not I can do deep learning.
Thank you so much for sharing your experience. I'm sure that was very impactful to women entering the STEM field and all individuals entering the STEM field, to give them a lot to think about going forward and really emphasize the importance of a support structure. Our next question pivots to a different topic. This question is from a rising senior majoring in clinical health at FSU. They were curious as how to get involved in more research opportunities involving psychiatry. Their passion is mental health, and they'd like to volunteer or shadow or do research in the fields, but they've had difficulty breaking in to have those opportunities.
So I will be the first person to admit that I'm probably not the best person to consult if you want to do psychiatry. It's a very different field. I know people that have looked for clinical psychology, Ph.D. programs, or psychiatry through the med school route. And it's the kind of thing you can't get in straight out of undergrad going into those kinds of programs. And they have very specific things that they want to see and skills and boxes that you need to check. I'm not a great person to consult with that because I haven't had to go through that process. And research is just very individualized. Anything that has more of a clinical spin to it is going to be more formulaic. That being said, if you're interested in doing volunteer hours, I would say the first thing that you should do is try to, approach any of your clinical psychology professors and see what kind of lab they're doing. In a lot of cases, they will have an EEG wing or just a questionnaire wing. Even if they're not actively doing research themselves, you can typically talk to them about how to start your own research study. Maybe they'll even mentor you. They can talk to you about how to put forth an IRB application and come up with your own questionnaire, so that way you can try to get a sense for yourself of what kind of traits do I see in the population I want to work with? What kind of skills do I need to do research in that field, if research is your focus? If you want to do the more clinical side of things, it's a great way to get involved in, clinical research. In most cases, people will like to see that you've had some sort of experience volunteering with that kind of population, and a lab setting is a perfect environment to get a first introduction.
So our next question deals with your experience in a lab setting. They want to know what skills you have found to be most interesting and most useful in your research, and what do you like most about your research? Lastly, they would also like to know what things did you have to improve upon from when you first started your research to now?
Awesome. This is probably my favorite thing to talk about. So my approach to research is the mentality that I am constantly failing upward. And really, that's the mentality that I believe everybody who goes into a research field should have, because we're doing groundbreaking stuff here. If we weren't and somebody's done it before, then I wouldn't need to research it, right? So we're constantly pushing back that line between what is known and what is unknown. And when you are there, you need to be comfortable with the fact that you're probably going to fail, and you'll fail a lot. That being said, it's never a failure if you learn from it, and a negative result does not mean you failed. So it might mean that your hypothesis was not correct, but it just means that you learned something else from it. And that's totally okay. So I'm a little bit biased because I'm in computational neuroscience. To me, and from what I've seen, computational skills, coding, statistics, applied mathematics, physics, those are the most helpful in my immediate field. It's the kind of thing that can really set you apart in an application if you have strong quantitative skills, if you even know the right kind of statistical tests to use. Seriously, if you just can look at your data and know, oh, my data are not normally distributed. Instead of using a t-test for significance, I need to use a rank sum. And the p-value doesn't really mean a lot by itself, so I've included the effect size here. And that tells us just how, just what we're looking at. Is it, a tiny little it's like statistically significant, but it doesn't actually mean anything, or this is a real result that we need to pay attention to. And those kinds of skills are huge. It can be if you want to go into, clinical cognitive psychology research, social psychology research, more on the biology or biochemistry side of things, just being able to process your data and knowing I can do the stats myself. I don't need to send them out to a biostatistician who does stuff that I don't even know about and I can't, double check. So developing those skills, flexing those chops, that's huge, 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 and it's going to make you stand out. The things that I wish I needed to improve, or I think I should have improved on, things that I already have improved on, are also my quantitative skills, because I was the kind of person that never really liked math. It was always my weakest subject, which seems so counterintuitive considering how much applied math I use on a daily basis, but it's just not something that comes naturally to me. It's something I really had to work hard to understand. I'm still very much on the entry level, but I've seen so much improvement already. But definitely I love any sort of opportunity to develop my critical thinking, my applied mathematics skills. Just even though the numbers themselves, I don't really have to work with so much. It's not really, writing proofs or solving equations, but being able to say, to engage with these concepts like, oh, hey, if I'm trying to figure out the best way to say this in as plain English as possible. But, if we know that in this domain, taking a step from here to here has a further distance between that, and then you go one row below and that step is smaller, even though it's still just one step, you can know, oh, hey, what if I scale that, where instead of having a standardized size, I have, okay, well, this part of the data, I need to take a smaller step, so that way I'm not way out here. And then when I get down and the scale itself is a little bit smaller, I can take, I can take steps that have been titrated. And being able to engage with that is just something that I never had to do before I entered my current lab. And, I've got two people in my lab team that come from a physics background. One has his Ph.D. in physics, one has his bachelor in physics. And then you've got me, psychology major. And so I'm engaging with them about these applied mathematics and physics topics. And we're talking about traveling within geometric spaces of, machine learning techniques. It's crazy. And it's something that I want to improve on, but the only way that you're going to learn is by getting involved and having these conversations and being comfortable with saying, I have absolutely no idea, but I'm going to go find the answer and get back to you. So start now. Take classes, even if you think you'll be bad at them. Take classes, join labs, learn.
Thank you for expanding on the importance of interdisciplinary and computational statistical skills. I think that's something that a lot of people don't originally think of when they think of neuroscience and psychology research. Our next question pivots to talking about finding research again. They are a freshman looking for research in their second semester, and the professors whom they have engaged with are only looking for students who are sophomores and above. They would like to know your advice for getting into research earlier into their career prior to sophomore year.
So it's actually interesting to me. So most of the professors that I engaged with and I've seen were very willing to take on younger students. So I would say just continue to reach out to professors. Find somebody that wants to take a chance on you. And if you can't, and you're like, okay, I might just have to wait until I'm, a sophomore or a junior to get involved, find out, find other ways that you can engage with scientific material. sometimes it's, having like a grad student or an older undergrad become your friend and teach you the ropes of like, okay, this is how you read a scientific paper. Sometimes it means getting outside of your field a little bit. So if you're having trouble finding a lab, let's say in the biology or the chemistry department that wants to accept you, try psychology. See if they need any research assistance. Get a feel for doing something that might be outside your wheelhouse. And if you still can't and you're having a difficult time, just find skills that you can work on online. There's this amazing website called Coursera that has all of these free classes that you can take. You can take classes in so many different things, including machine learning and programming and math and statistics, and you can learn that. So don't let that time be wasted. You can still work on the skills that would make you a successful research participant in undergraduate research. But just keep bugging professors. That's my thing. I get rejected a whole bunch, especially during undergrad. That's something else that, if you enter research, you're going to get rejected a lot. And that has absolutely nothing to do with you and absolutely everything to do with the fact that there's just other factors at play. It's not even necessarily a competition. It's just there's a lot of factors going on behind the scenes that you're not necessarily privy to. So, might be that particular professor didn't have a great experience with freshmen being consistent in their research position. You might have others that are so desperate to have an undergrad join their research team that they don't care what year you are. They just want to show that you'll commit to their lab for 2 to 3 semesters. So just, be consistent. Say, and even say like, hey, would you mind considering me? I know you only want to take older students, but I really, really, really want to join your lab. Would you mind considering me anyway? Sometimes that's got a lot of power to it as well.
That is great advice. Our next question looks at the computer science side of things that you brought up earlier. They want to know what computer science research looks like and if there are programs available to computer scientists.
Yeah. There's so much computer science research, and it can be something as, it can be something more, within the comp sci program, and then you can have ones that straddle domains, so like bioinformatics, computational genomics kind of land. You've got research that you can do in artificial intelligence. So one of the things that my lab also does is in silico experiments. So we look at computer vision, and we're looking to see how we can apply what we know about the brain to artificial visual systems, which can help for self-driving cars and object recognition and detectors, things like that, and increase security in airports. There's so much research going on in a whole host of different areas. I'm more on the applied side of things, so I'm not really well equipped to speak about, just pure kind of theoretical, like quantum computing kind of areas of computer science research, but there's a lot. And it's the same premise as with biology or psychology or neuroscience research. Reach out to your professors, especially ones that, you've had in class, and say, look to see what their lab is doing, look to see what kind of research they're doing, and saying, hey, can I get involved? Can I even just sit on your lab meetings? Can we talk about this kind of stuff? And in most cases, they'll be just so happy to take on a trainee.
Thank you for expanding upon that. Our last question deals with, if you do want to incorporate programming skills into your neuroscience research, what are the most important ones to know for neuroscience research as it is now?
Wonderful, wonderful question. So what I have found most helpful personally is a programming language called MATLAB. It is a widely used language across many different disciplines. The thing about MATLAB is it's not a free language. You have to pay for a subscription to it. There is a free version online called Octave that has about 80% of the capabilities. That's a good place to start learning notations. MATLAB's parent company MathWorks also has amazing, like truly amazing free tutorials where you don't need a license. You can go online and do their tutorials and start to get a feel for how this language goes. other than MATLAB, the other one that's frequently used in research is Python. Python is a free language. It has so many capabilities, especially if you want to get something more, if you want to go more into the deep learning, machine learning side of things. That being said, Python and I have a strange relationship. MATLAB and I are best buds. I'm really comfortable with it. I'm a little less familiar with Python. There's a lot of different nuances, and probably the best thing to do is to go online and find a free course on Coursera that gives you an introduction to Python or to another programming language that would be helpful. But if you like, if you want to work with TensorFlow, definitely learn Python. If programming's not really your thing and you just want to know enough to get by in lab to analyze your data, I would recommend either learning MATLAB or R. Most labs will do stats in one of those two. I personally prefer MATLAB for stats. I don't really like R's notation as much, but don't tell the others. But yeah, don't tell R Studio.
Awesome. Well, thank you, Olivia. Was there anything else last minute that you wanted to just recognize before I give everybody a few resources?
I would love to just take the opportunity to, one, thank each and every one of you for attending my talk, and also acknowledge the amazing people that both WashU and FSU that helped me on my journey. I have a couple slides that I'll share again. So I want to recognize my amazing lab team, including Carlos, my amazing PI, Binshu, Mary, James, Katie, Victoria, Jeevan, my 4 monkeys, the National Eye Institute that funds my graduate career. Also, everybody at FSU who helped me get to that point, Dr. Wen Lee, Dr. Derek Nee, Dr. Zixin Wang, Dr. Sarah Baisley, Kevin, Megan, Jeff Badger, Amy, Jessica for helping put this whole thing together, Dr. Bertram, everybody involved in UROP, the CRE, the Honors and Scholars and Fellows House, SCIRC, and Phi Beta Kappa. You all are just absolutely wonderful, encouraging people, and I am just so grateful that I get to say my research career begins with everything that happened at FSU. So with that, I would like to say, go forth, good luck, you can do this, you will be amazing. Amy will provide my contact information. Please feel free to reach out if you have any questions. I'm more than happy to Zoom or email. Just let me know what you need. And then I also have a little sheet of resources detailing some of the things that I talked about today, as well as some other ones that I haven't had the chance to touch on. Hopefully that can be a good guide and resource as you move forward throughout your undergraduate career. And I hope to see you guys at Society for Neuroscience, the big neuroscience conference in the future.
Thank you, Olivia. And like she said, she did take the time to create this awesome resource page that for some reason Zoom is not sending to you all. So I'm going to send a follow-up email with the recording of this session and with that resource page so that each of you have that. I'm going to put a few links in the chat right now. First, I just want to thank you, Olivia, again for being here. And for just sharing all of your knowledge with us. And thank you, Jessica, for moderating. I also wanted to say, if we didn't get to your question today, or if you had any additional questions, please feel free to email myself or Olivia. Both of our emails are now in the chat, and we'll be sure to answer any of those lingering questions. And she also just offered a Zoom session. So she's very willing and able to assist you all. And then what I also wanted to say is the recording I'll send out to you all. It'll also be on the YouTube channel starting tomorrow. If you want to learn more about what we offer in the Honor Scholars and Fellows House, which she touched on a lot, please visit the website that I've put into the chat box. It elaborates all of the undergraduate offices and programs in the building, and specifically CRE, since I know she talked about that a lot, in the UROP program. So feel free to go to that website and check it out and get involved. And lastly, I just want everyone to keep an eye out on social media for our future speaker series throughout the fall. Our next one's going to be on September 14th, and you're going to hear from an alumna discuss how to effectively choose a master's degree. So as you'll see, all of our topics throughout the semester will be very specific, but we want to make sure that we reach all of our students and all of our students' interests. So Thank you for coming today, and we hope to see you again virtually in the future, and stay well. Thank you.